Okay, so here is going to be a quick video on some tips and tricks on how to compare numbers in scientific notation. And so there's really two ways that you can, well, I guess there's probably multiple ways, but just something to think about. So let's say we have 3.25 times 10. I'm going to change my color. So 3.25 times 10 to the third power. And then we're going to compare 1.67 times 10 to the third power. Now really, if they have the same power of 10, so right now we're looking at 10 to the third power, then really all you have to do is look at the coefficients to compare them. Very simple. So because they have the same power of 10 and 3.25 is a larger decimal than 1.67, this 3.25 times 10 to the third power is going to be the larger number. Let's do another example. So another example would be 5.68 times 10 to the negative fourth power. Bringing in those negatives. I know they're scary, but they don't need to be scary. And then 4.26 times 10 to the negative fourth power. So again, look at these power of 10. They are the same. So now we can look at our coefficients. So which one is bigger? 5.68 or 4.26? This is our larger number. 5.68 is larger. You can also pick out the smaller number too. All right. Our next one that we're going to do, now we're going to step it up and challenge ourselves. We are going to look at when the numbers are different powers of 10. So 3.78 times 10 to the seventh power. And then we're going to do 3.36 times 10 to the sixth power. So even though our coefficients are fairly close, if we look at our powers of 10, we have 7 and 6. And because 7 is bigger than 6, then our larger number is going to be 3.78 times 10 to the seventh power. All right, this is where it starts to get a little more complicated when we are working with negative numbers. So let's do 2.6867 times 10 to the negative third power. And we are going to then do 1.93 times 10 to the negative second power. So looking at these two numbers, they have different powers of 10. Their coefficients are similar, but they're close. But we can right off the bat see that their powers of 10 are different and use that to compare them. So here we have -3 and -2. Now you're going to have to put a little bit of thought into this. Which one is bigger, -2 or -3? Even though this value 3 is larger than 2, they're negatives. So -2 is actually larger. So we have our larger number is 1.93 times 10 to the -2nd power. All right, we're going to do one example of how to order multiple numbers. Okay, so let's say we have 326,000. Then 3.1 times 10 to the 4th power, and then 3.3 times 10 to the 5th power. So if you had to put these in order from least to greatest, what I would suggest doing is converting this number, the number in standard form, to scientific notation. So we're going to do that. 1, 2, 3, 4, 5. So that becomes 3.26 times 10 to the 5th power. And now you just look at your exponents and your powers of 10 and your coefficients. So right off the bat, I see we have 10 to the 4th power. So that's my smallest number. So 3.1 times 10 to the 4th power. Then we have 10 to the 5th power here and 10 to the 5th power here. We have the same power of 10. So you're going to then look at your coefficient. And 3.26 is smaller than 3.3. So my middle number is going to be 3.26 times 10 to the 5th power. And my very last number is going to be that 3.3 times 10 to the 5th power. And then you would follow that same process with negatives. If you don't have paper, I would get out a piece of paper and pencil, especially if you are doing this on Schoology, and write them down. Write your conversions down on a piece of paper so you can order them.